Hello, here's our first video in section 2.2. You probably noticed we skipped section 2.1, or you might be noticing it right now. That's sort of an optional application heavy section that I think we'll come back to in the end to use it as a review and something extra later on when we're like reviewing for the final, if we have some extra time. For right now, we're going to look at systems of linear equations, and here's our first example. We'll see how to solve a question like this by setting up equations, because it's going to actually require two equations that we'll see, and solve it using a graphing calculator. So let's read this first. So this is information that you might have if you're a biologist, let's say, for example, and you want to know how much the average thrush weighs. It's a little bird. How much an average robin weighs. And you set up a bird feeder like this situation here with a scale on it so you can see how much the bird weighs. Unfortunately, the bird food is so delicious that you don't just get this nice situation where there's one bird eating it and you can just see the weight and just say, oh, it's that much, whatever that is. Because you don't just have one bird, because you got a ton of birds on it, because these are hungry birds, apparently. And so if you have a bunch of birds on it, you have like 3 thrushes and 9 robins on it at one time. And you probably have this like set up with a camera in the woods if you're a real biologist, and you're trying to get all the data you can, and you have the camera on the scale, and you can count how many birds are on it using your camera after all of it's been recorded. Anyways, at one point there's 3 thrushes and 6 robins, and the total weight of those 9 birds is 48 ounces. And then there's 5 thrushes and 2 robins, and the total weight of those 7 birds is 32 ounces. So how much does an average thrush weigh? How much does an average robin weigh? Let's see what we can do. First thing to do, once you understand what's going on with an application problem like this, is make up variables for the things that you need to know. It's asking for the average weight of thrushes and robins, so just define the variables like so. When you do this, it's always important to use the units. In this case, if you're talking about weight, you know the units of that are ounces. Sometimes you might have problems with mixed units where some of the ounces are, or some of the weights are in pounds, and some of them are in grams, and some of it's in ounces, and you need to keep it all straight. And sometimes you have problems where there's things moving, and you might have miles per hour sometimes, and some of the variables are going to be in hours, and some of them are going to be in miles. So it's an important thing to just make sure you're keeping track of that. Anyways, now that you have this, let's write out equations that describe what's going on here. The general idea is that at each of these different times with the different birds, the total weight of all of the birds adds up to that number. So you can break down that 48 ounces as the weight of the thrushes plus the weight of the robins with equations that look like this. So we need to turn this stuff into expressions using our variables t and r. So if there's, let's look at the first situation, 3 thrushes and 6 robins, the weight of 3 thrushes is going to be approximately 3 times the weight of a thrush. So that's going to be 3t plus the weight of the robins is going to be, the weight of 6 robins is going to be approximately 6 times the weight of 1 robin. And that should add up to the total weight of all those is 48. Likewise, 5 thrushes are going to weigh 5 times the average weight of 1 thrush. 2 robins weigh 2 times the average weight of 1 robin, if these are indeed average robins, but that's our best guess. These robins might be a little heavier or lighter than an average robin, but we have to make our best guess and assume that these are average weight robins if we're going to get the average weight of these robins. It should work pretty well. Okay, now how can we now find out what is t and what is r? So far, this just tells you an equation, But what we want to do is we want to find a value, a number for t and a number for r, that makes both of these equations work, that could describe both of these situations with the bird weights. So to do that, we're actually going to graph these on our calculator. I'm going to rewrite these in terms of x and y first, because the calculator doesn't know what t and r is. Like so. Now, if you want to graph these on your calculator, remember you have to solve it for y in terms of x. So that means get it so it looks like y equals. I'll skip the steps here. I recommend trying it on your own, but we did a bunch of these last time, so I'm not going to actually record myself doing all of it. So here's equation 1 solved for y in terms of x. And after doing that work, these are now solved for y in terms of x, which means you can graph it with a calculator. So to graph it, let's open your calculator so you can follow along. So here's the calculator screen. This is just a regular blank screen, like when you turn it on. The home page or whatever you call this thing here. Now, to get to where you plug things in, press y equals. Oh, I still have something left over from the last video. So we're going to clear that. We're going to graph y equals 8 minus the fraction 1 over 2 times x. And the second equation should look like that. Remember, the X button is this red one here. Don't do the alpha X over here. That's going to do the wrong thing. So we can graph it now and see what it looks like. Okay, we get a decent graph over here. I want to be able to focus on this area a little bit, so I'm going to mess with the window. Window button. I want the X max to be a little bit bigger so I can see farther to the right there. So let's make that be, I don't know, 8 should be good. It was already good enough, and we don't really need to go this far down. Let's try that again. Okay, so now you can pretty easily see, and you could get and let's think about what we're trying to find here. We're trying to find an xy point. Remember, x here represents the weight of a thrush, y represents the weight of a robin, and we want one value of x and a corresponding value of y that will make both of these two equations true. Now, this graph, this first line here, that one with a y-intercept of 8 here, that represents the first set of birds you had, and the second one represents the second set of birds you had. And there's an infinite number of points along each one of these lines. Each one of these points represents the possibilities that you could have for the first scenario, which was the 3 thrushes and 6 robins that weigh 48 ounces. There's a lot of ways that could happen, but there's only one way that the second one could also be true at the same time, and that happens at that intersection point. So we want one xy point that works with both of the equations, so that's got to be that point there. Now, to get it, you could get a rough estimate by pressing trace and getting sort of close to there, but it doesn't always work out perfectly, because what if the exact intersection point isn't right on one of these pixels? You're kind of going over by 1 pixel each time. So that's not very precise all the time. The best way to do it is as follows. You see the calc menu here up above trace. So I'm going to hit second and trace to get that calc menu up. And we want to find the intersection of 2 lines. So I'm going to scroll down to that, or you just press number 5, enter. Now it's going to ask me for which curve, and it says y1 equals this equation, and if you hit up and down, you'll go to the other line. But the only reason it asks you this is because sometimes you might have like 5 curves, and you need to tell it which 2 curves are you trying to find the intersection of. So in this case, there's only 2 on here, so it really doesn't matter. Just hit enter again, And that says the second curve. Well, there's only one other curve, so just hit enter again. And then you can make it a little easier on the calculator by guessing. And it tells you the precise intersection right there. So that means that the value of x that will make both of these equations work and the value of y that will make both of these equations work is going to be 4 and 6. So we can now try to answer the question and check that it works. But it is really important to check your work. I consider this really part of doing the problem, to actually make sure that these equations work in the original, that these numbers work in the original equations. So what that's going to look like is like so, plugging in 4 equals t and 6 equals r into the original equations that we set up. And the reason why you need to check it here, you're not checking that the calculator did it right. What you're really checking is that you did all this other work right here, and also that you plugged it into the calculator correctly. Because to get it ready for the calculator to know what to do, you had to do all these steps here. And if you made a mistake in this part, then maybe this equation wouldn't actually be equivalent to the equation you started with, like you think it is. So this is checking that all your work worked out right. It is actually possible that the thrushes could weigh an average of 4 ounces, and the robins could weigh an average of 6 ounces. And whenever you answer a question like this, I always want to see units if you're giving a number which represents a real-life quantity, like a weight of something, or how much money something is, or how far away something is. Those always need to have units. Now, here's a thing for you to do. Try to solve this system of equations, just to practice it using your calculator again on your own. Here's a good window to use. And then check it. And I do want to see you checking that it's right. Now, if you don't have a graphing calculator yet, because it's still on the way because you ordered it from Amazon or something, I will show you how to do this on Desmos.com right now. If you don't have your graphing calculator yet, you can still do these problems for now using the internet, which you can't do this on a test because of all of the other stuff on the internet that you're not allowed to use. So, but at least you can get the idea of what we're doing right now. I just went to Desmos.com, plugged these in. I clicked the Start Graphing button at the beginning and just typed these in, and it will graph them automatically. Now, we need to see what is the xy point that satisfies both of these equations. It's going to be the point on both of them. With Desmos, it's actually really nice. You can just tap it, and it will tell you the point is 7, 2. And to actually verify that it satisfies both equations, I didn't want to do this difficult arithmetic by hand, so I just plugged it into my calculator. I plugged in x equals 7 into the right side of each of these, and that made the right side come out to be 2, which will, of course, work if the left side has 2 plugged in as well. So that's that. Sorry this video was a little bit longer. I hope you sat through it, and I hope you're able to follow along with this, and I'll see you later in class after you do another video or two.